Okay, hello and welcome everyone to this special webinar today. My name is Ilya Kanouhov and I'm the Senior Development Manager at World Forum Offshore Wind. Today's webinar is on floating offshore wind dynamic cables, white paper highlights. It's my great pleasure to welcome our excellent panel for today, including WFO's Chairman, Cables and Floating Substation Subcommittee, Hayden Marcollo. Then we have Ralf Skowronnek, John Baxevanidis, Michael Borg, and Osman Gijapali. And before we jump into the presentation, let me tell you a few things about WFO. The organization was founded in 2018, and we're a non-profit entity focused on offshore wind energy only. We promote offshore wind energy worldwide. Our members represent the entire supply chain, and we have an international offices we set up in Hamburg, Taipei, and New York. And in terms of our activities, it's very straightforward, as we focusing on periodic reports. We facilitate various working groups, and we organize events for connecting the offshore wind community. And talking about the events, feel free to join for our next event, which is going to be in Tokyo, in Japan, in about 2 months from now, and this will be WFO Asia Pacific Summit. Those are our members. We have 120 members at the moment. They represent the entire supply chain. And if you're not a member yet, feel free to contact our managing director, Gunnar Herzig, and he'll be happy to provide information how to join us. And a few words about this webinar, which is actually very simple. During the first half, Hayden will provide a brief overview over the published white paper, and then we'll have a panel discussion. And then at the end, if we have time, we have a Q&A session. So without any further ado, Hayden, the floor is yours.
Thank you, Ilya. So we're pleased to be joined with the panelists today to discuss the white paper highlights and their insights into dynamic cables for floating offshore wind. And we've gathered together a great set of panelists here, bringing their own expertise from their own areas. I just wonder if, before we get started, each of the panelists can just give a very quick introduction to themselves, maybe 20-30 seconds, that's possible, so that everybody can get an understanding of your expertise in the area. Can I start with Ralf?
Yes, sure. Thank you very much, Hayden, and hello to everybody for this very nice webinar about a very nice white paper, which I think. So I'm Ralf Skowronnek, insurance engineer, 30 years now working in the international insurance business, 17 years in offshore wind, and I'm the chairman of the subcommittee insurance of the World Forum Offshore Wind, and happy to be here today.
Great. Can I pass it over now to John Baxevanidis from Exsto?
Yes, hi Hayden, hi everyone. Thank you very much for the opportunity and the invitation to participate and share with you. So yes, I'm John Baxevanidis. I work for Exsto. I'm the business director of our subsea business, and my background is 20 years in the oil and gas. I started from engineering, and yeah, there you go. And little by little, I moved into commercial management, always in the sort of subsea cable protection environment, if you like.
Okay, great. Now, Michael Borg from Stiesdal.
Yeah, thanks for the invitation to the webinar. And yeah, my name is Michael Borg. I'm a chief engineer at Stiesdal Offshore, and I'm responsible for system engineering. So it's covering global design of the foundation, mooring, cable, interactions with wind turbines, and concept development. And I've been in floating wind since 2011, around 13 years. Thanks.
Excellent. And Osman Gijapali, can you please give an introduction?
Hello, everyone. Hi, Hayden. Yes, very thrilled to be here today, and hello to the audience. I have more than 8 years of experience in offshore wind. First, from the commercial perspective in cable manufacturer, Prism Group, and later on, I'm now in a Jumbo Consulting Group as a senior consultant manager, and we support developers across the global market from different perspectives in all sorts of packages, and specifically on the cables. Hello, everyone, and nice to meet you.
Great. Thank you very much. So you get a flavour now for the different panelists we have here, and I'll provide you now just a fairly quick overview of the dynamic cables white paper that we released. So just going through some of the highlights of the white paper to set the tone, and then we'll go into some discussions with the panelists, as Ilya said, and then have some open Q&A. So Hayden Marcollo from AMOG, and I'm also the WFO chair of the Cables and Floating Offshore Substations Subcommittee. We've been doing this committee for about 2 years now, and this has been the sort of groundbreaking deliverable that we produced from it. I also must acknowledge the tireless work of Louise Effimu behind the scenes, who works for WFO and has put together a lot of this white paper and coordinated a lot of the activities. Can you go to the next slide, please? So the WFO and the Floating Offshore Wind Committee is shown there with the organisation. There are 5 subcommittees. The one on the right at the bottom is a new one, Environment and Biodiversity. So it gives an opportunity for members to have technical detailed discussions and hear the latest information on all those different subcommittee areas and topics. So if you're not in the WFO, I encourage you to look seriously at joining. It's the leading discussion forum for technical issues in the floating offshore wind industry. Next, please. So here's just a summary of some of those subcommittees. There's the Cables and Floating Offshore Substation one there on the left. The Moorings one is chaired by David Timington of Griffin Woodhouse. The Operations and Maintenance one by Ilmas Baidi of Peak Wind, and the Insurance one from Ralf Skowronnek, who's here today. Next, please. So some of the key takeaways from the white paper, the Dynamic Cables white paper that we released in February. We looked at the future of offshore cables and setting the scene for what the purpose of offshore dynamic cables are for. There's going to need to be 2 main technological advancements. There's a need for higher voltage of inter-array and export cables as power requirements increase. The efficiency needs to improve, so we need to move to higher voltages. And we also need to look at design optimization for dynamic inter-array and export cables. So looking at technical risks as well as reducing OPEX and CAPEX considerations. Next. If we start by looking at the cable configuration, and this is care of BVG and ORE Catapult in their guide to an offshore floating wind farm. Then we look at ancillaries that are involved in the dynamic cable configuration. They help maintain the shape throughout the water column and protect the cable from overload and fatigue. A lot of this equipment is adapted from the oil and gas experience, but it differs in size and fatigue load regimes. An example of things that may need to differ in floating offshore wind compared to oil and gas is that dynamic bend stiffeners will need to have multiple latch and unlatch cycles for the ongoing disconnection, potential disconnection requirements of floating offshore wind. And other issues are the temperature of the electrical cable that might operate and cause issues there. Next slide. So the white paper summarized the fundamentals of cable configurations for floating offshore wind, and one of the issues with coming up with configurations and what the cables may look like is you have to consider the loads acting on cables. So dynamic inter-array and export cables need to withstand higher loadings from environmental forces. So if you look at the left here, there's environmental loads acting on the cable, which can be current, wind, wave forces. And then there's the displacement and motions of the floating system and the resulting stresses that puts into the cable configuration. So first order motions due to the waves, wind dynamic effects, second order motions of the floating system, all those to be taken into account by the cable. On the right are some of the key issues you need to look at in optimizing the configuration. So making sure that there's no compression that's limits that are exceeded in the cable, that the MBR or the minimum bend radius, which is inverse to the curvature, is not exceeded, that there's enough sea surface clearance in the case of vessels accidentally driving over the top, and that regions like where the dynamic bend stiffener is and the hang off protect the cable from excessive curvature. Next slide, please. So the cable global layout is something that we considered and looked at what various people in the industry are thinking, and there's some configurations shown here that were also shown in the white paper, and then we discussed in the white paper the various pros and cons of different configurations from a redundancy perspective and from a reliability perspective. Next slide. So we're just looking at the bottom fixed experience, so fixed offshore wind experience in terms of the cables, because that's the biggest database we have at the moment of cable failures, and that to rely on to try and draw predictions on what might happen with floating dynamic cables. We see huge amounts of failures caused by installation considerations. So mitigation measures that are needed across the whole life cycle there. Quality site surveys, subsea cable, manufacturing installation observations, and the need to publicly communicate issues that have happened in the past. Next slide, please. From an insurance perspective, and there is the risk mitigation that needs to be considered. So lowering the probability of failure in dynamic cables. So looking at redundancy issues. And there's the loss mitigation. So the reduction of repair cost and downtime. So these factors that affect those things are replaceability of the components and spare parts plans. At the bottom there, we're looking at the different insurance legs that are potentially covered. And Ralf will likely talk a little bit about this later. Next slide, please. So the white paper summarizes 4 industry priorities for floating offshore wind dynamic cables. And the first one there is the need to develop dynamic export cable standards. So dynamic export cables are the new element in floating offshore wind systems that hasn't existed yet. So we have dynamic inter-array cables, but we don't have large diameter dynamic export cables. So from a central substation collection area where there's going to be the need to export high voltage, high power, we don't really have any standards on ensuring the design, manufacturing, installation and operation of those cables. So that's really a really high priority we saw. The second is to develop wet connector technology, so the ability to plug and play systems easily with low cost is seen as a high priority. The third one there is to develop holistic engineering approach, so designing the cable system with the mooring system in mind and the floating offshore wind system. So looking at the complex installation and maintenance strategies that are involved in the holistic approach there to reduce the overall costs. The last one there is to adopt integrity management philosophies right from the design phase. So next slide, please. Just looking a little bit more in detail at some of those things. Cable integrity management. Cables can fail from a variety of reasons. There's some shown there, including shark bite. So the opportunity to monitor for predictive maintenance is seen as a important aspect, important thing to do. Next slide, please. Holistic engineering, so just looking at global analysis of the system when it's being designed, a local analysis of components, and then fatigue testing of components, making sure they're qualified, that they've passed all the system integration tests is an important aspect there of the holistic engineering. Next, please. Wet connector technology, so this will enable the easy change out of floating systems, less potential for multiple units to be subject to downtime, more streamlined hookup. So potential to decouple a lot of the installation sequences. Next, please. Dynamic export cable standards. I talked about this just before, and there's just an arrow showing that dynamic export cable, the location of it there off the floating offshore substation. Obviously, in the real life, the floating offshore substation isn't going to be that close to the shore. Otherwise, you wouldn't need it. You just take the cables to the shore. But we're talking about long transmission here. Next, please. And this is just about the summary of dynamic export cables standards. And so you can see there some of the standards that have been progressed of late. The white paper has a good summary of all the standards that exist at the moment from the different groups. So I encourage you to look at that if that's something of interest to you. And final slide, please. This is just a nice artistic image to finish on of an electrical and water tree image from the University of Manchester, showing what happens when insulation breaks down on cables and there's high voltage across that insulation, and the degradation of the insulation occurs with this sort of beautiful tree image, which is beautiful for artists maybe, but probably a bit worrying for operators. So with that, we'll move now to the panelists and some of their involvement, some of their comments on floating offshore wind issues. And perhaps we'll start with Ralf. Ralf Skowronnek, who is the insurance subcommittee chair, as he introduced before. And I was just wondering, Ralf, if we could get your view on what's the insurance perspective on cable design classification?
So great to give me the first job. Thank you very much. Yes, okay, let's start. Ilmaz, if Ilya, if you could go on the insurance slide, please, in the meantime, so that I can jump a little. Just for your information, so I'm because some of once again people do not know me. I'm not working for an insurance company. I'm working regularly advising clients as a risk and insurance advisor, and what we are now talking about is only the reflection of an industry, of insurers, on which, let's say, which is very important for the future, for future projects, because the number of insurance companies being capable and willing to underwrite these risks in offshore wind in the future is relatively low. Yeah, so we have to do a lot of technical risk mitigation work, and the most important is we have to address this to the insurers at a very early stage. So this is one of the roles we are doing in the subcommittee insurance together with the technical committees on behalf of the WFO, and there is no other organization where this is done on such a basis. And we already had some, I think, some very good learning curves, and also the projects which are participating regularly at our meetings, I think will already have learned a lot, perhaps already changed their internal process a little, starting with the design, because we are talking about these issues for, in the meantime now, nearly 4 years. So in September, it will be the 4th year already. So to make it short, with respect to cables, the major thing is, so what everyone should never forget is that once we are starting to talk about wear and tear, and this is very often discussion during the operational phase later, then this is no longer an insurance case. So wear and tear, very shortly, is not insured by any insurance, which also means once it starts a discussion with insurers about gradual deterioration, which is very similar, also this will be a negative case for us with respect to the possibility to gather insurance coverage. And the second thing is loss of revenue coverage is only given if you are fulfilling the physical damage aspect. So if on the other way around, if you have a loss which is caused by wear and tear, you will never receive any coverage for the resulting loss of revenue. So because simply the physical damage was not insured. Yeah. So what does this mean with respect to cables? Insurers are very interested to see, with respect to the installation phase and the manufacturing phase, that already risks have been mitigated, which later could lead to further losses or damage to the cable. So they are relying on the marine warranty surveyor for the installation phase, so which is a pre-transportation and installation phase to be completely on the line, and everyone is invited to also, as an engineer not working in the insurance industry, to have a look into the JNRC 2021 marine warranty surveyor standard, because there is a scope of work which exactly is listing the tasks and which a marine warranty surveyor is fulfilling from the very often from the FAT, from the factory acceptance test of the cable up to the end of the installation. So this is number one, and this has to be fulfilled, otherwise no coverage is given under the construction insurance policy. The second thing is that, and this is obvious, and this is already started during the insurance placement process. So as information for you, the placement of the project insurance policy very often starts already 2-3 years before the real project is starting. Yeah? They are relying on certification process, which is not at the moment for floating offshore wind, for dynamic cables, is not finally completely agreed, but if we are looking on a certification, type certificate for the cables under discussion from a well-known certification body, then definitely we are already on the right side. So this has to be provided by the broker in his underwriting submission to insurers, because otherwise placement of the policy is not possible. Now, as an engineer, you will say, yeah, but 2 years before the start of the installation, how should I do this? Because it's not possible. So very often I don't have a type certificate at this point in time. Yes, agree. You have to include these as subjectivities in the underwriting submission and in the policy. And then later, at the later stage, once the policy has been concluded and started, then you are, during the regular update meetings with insurers, you are delivering these certificates step by step. Insurers are very much aware about the failure rates of floating offshore wind with respect to mooring lines and cables. So they are aware of that. So also no problem to hide this because it's an open discussion, and I think we should discuss this openly, because this immediately leads to the perspective I also have as risk engineer, and also in former times I also was working as loss adjuster for insurance companies, so I saw a lot of losses. It is of highest interest for insurers already to have the loss mitigation solution at hand, because the loss mitigation solution is reducing the consequence, which is reduction of repair costs, but very often much more important, reduction of loss of revenue. Yeah, so which means, for example, when we are looking into design as one example, it's a very positive feature if a project can, from the layout at the starting point, already show that, for example, there is the strings are not single lines, or for example not only daisy chains, but for example they are connected, so that in case in a ring, so that in case of a damage to one of the cables, we don't have 5-6 turbines out of operation, but we have simply the same number of turbines working, but perhaps with a lower power production, yeah, because of the cable capacity. So this is a very, very important information, one of the information to insurers. So to make it short from my side, before we hand over to the others, of course, consequence, most important thing, repair cost reduction, loss of revenue reduction, and these are things for you to consider, because they are not automatically covered by the certification process.
Right, there's the issue that you have a long deductible as well, and that not everything's covered. So insurance is becoming a really, really important issue, and becoming a larger proportion of the capex of the overall project. So it's really
Exactly
important issues on insurance. Thank you, Ralf. And we may have questions on that in the Q&A session. But if we look now at some of the other challenges and key components that I was talking about before, one of them was the dynamic bend stiffener, where the cable joins to the floating system. And we do have an expert in that area here, John Baxevanidis. So can I ask you, John, a bit about those, and what do you think the main challenges are with adapting dynamic bend stiffener technology to floating wind dynamic cables?
Yeah, sure. Thank you, Hayden. I mean, for us, I think there are two areas that are kind of popping up a little bit more than sort of the oil and gas supplies, traditional oil and gas supplies, if you like, for the dynamic bend stiffeners, and that's the as you alluded at the beginning of the presentation, is the issue of temperature and connectivity for the bend stiffeners. For example, we did a presentation last year. We have done some work on the effects of temperature on the bend stiffener and the cable. We used kind of a dummy cable. It is suggested that perhaps the next step, it would be to use an actual cable, run some current through it, and do another full-scale test. So that will be the next step, perhaps in looking at in more detail at what high temperatures can do to the bend stiffener and the cable as well, on all the sort of components, the insulation components of the cable. So that's one area, and then the other area, as I said, is the connectivity aspect. As you said, it seems to be it's an important issue of the latching, unlatching. What is a little bit confusing for us is, and that's, I think it's, if I could step back, it is a theme that permeates across so technical and commercial challenges for the cable accessories for us, is the sort of the lack of clarity, the lack of technical data and specifications at an early stage, which I guess everybody complains about. It's perhaps systematic of an emerging industry, I guess. But that is a real challenge to kind of determine and have good, accurate designs, at sort of an early tendering or bidding stage. For me, it's something which, it's a great difficulty for us when we don't have any, fatigue data, for example, and stuff like that to accurately size the parts, and also with over 100 floater designs out there, we're asked to sort of design parts that we don't really know at this stage where they're going to go, how they will be installed, and all that kind of stuff. It's quite difficult to sort of determine and be accurate. So yeah, I mean, I would say that's and as I say, it permeates across contractual and structural and commercial issues. For example, who is the supplier of the connection for the bend stiffener? Is it us? Is it some? Is it the installation contractor? Is it the cable manufacturer? Is it the floater designer? We keep asking these questions. We're getting kind of everybody is on the same page, if you like, in the sense that no one really knows exactly what is going to happen. But yeah, these are the issues that today are a bit sort of challenging for us, if you like.
Great. Yeah, just trying to figure it out as the industry matures along the path.
Yeah, and if I could just add one last thing, is perhaps that something that I heard a little bit more on Wind Europe recently, that I hadn't heard before, and that was a few people calling out for kind of a stop to the continuous innovation and the use of perhaps what we have today in terms of capabilities and know-how to at least kickstart the industry, rather than sort of continue and developing, more and more and more new concepts and floater designs and all that kind of stuff. That kind of resonated with me. I thought it was, why not? Because up to now, everybody's promoting this kind of, we need to innovate, we need to reinvent the wheel a little bit. But as time is running away from us, and the targets seem further and further away, perhaps it's also a good point to use what we know today and what we have today to at least make a start.
Yeah, use the high technology readiness level components that we have now. Yep. Great. Thank you, John, for that coverage. Pass over now to Michael Borg, who is from Stiesdal Floater Design Company. And Michael, how can you comment on how you think floater designers should be taking into account cable designs in the early project development phases?
Yeah, essentially, sort of with quite a strong alignment with this recommendation for a holistic approach to the engineering of the whole system, rather than trying to design the wind turbine, the floater, the mooring system, the cable in isolation or in a semi-decoupled fashion. So first and foremost is really taking this holistic approach and doing an integrated design, even from the early stages, because especially wind farm developers, they're interested in having a design that can be assessed from a cost perspective quite early in the process of developing a farm, to be able to take the decision of whether to proceed further with developing the farm. So it's quite important as early as possible in the phase or in the project's lifetime to get a system that works together that is cost effective. So this is where we at Stiesdal, we don't only do floater design, we also are doing integrated design of the floater, the mooring system, and the cable system, together also interacting with the wind turbine, because that also drives the design choices within the whole system. So that's quite important, especially for challenging sites that can be relatively shallow, which is what we're seeing as some of the first sites, for example, in Scotland and other places in the North Sea. The sticking to traditional dynamic cable system configurations will require mooring system that basically will put a project having not a positive business case, so it will not fly. So essentially, there has to be some innovation, but I agree with what John said before. We cannot continue to innovate because you'll never industrialize then, and you never bring the cost down per unit. So it's only in certain places where I think, especially in the short term, or to make the first commercial projects work, we have to do that. So one example there in relation to the cable is traditionally the cable has been a semi-custom or custom design per project. So you only have some limited testing, and the standards that are out there are relatively conservative in what design factors to use, what buffer you have to include or consider. And so it would make more sense maybe to have some standard cable cross sections that are supplied by manufacturers that are much better understood, and you can push the design envelope much larger or to a more significant extent on those cables that will facilitate system design, so including the mooring system that is feasible from a financial point of view. So that is where we see this interaction between the mooring system, the floater, and the cable going. And that also can result in, for example, especially in these challenging sites, which are relatively shallow waters, we're talking below 130 or 40 meters or so, and harsh sea states, that you may require a more complex cable system design, so with more ancillaries attached to it. And that would initially look quite cost prohibitive, but when you look at the global picture, so what does it cost, the project cost as a whole, the savings, for example, made on the mooring system relative to the increased expense on the cable will still make the total cost of the system of the project cheaper. So it's also taking that approach rather than focusing on the individual cost of each subsystem of the whole floating wind farm. So I think that is where we would like to, or would recommend going towards, and also not just considering even in early design stages, not just considering the in-place performance from a technical point of view, so as it is installed, but also how are you going to install it? Is it going to be, especially from a wind farm point of view, are you going to try have synergies with the mooring installation to sort of minimize vessel costs? Because that is one of the largest cost contributors from a T&I point of view, and you want to try and minimize that. Likewise, thinking about that, the interface or the connection between the cable and the floater itself, trying to simplify that to minimize the use of or the need of personnel on board, maximize the weather windows that you can have for doing the operation, and minimize the vessel spread that you need to do that operation, because that can very much drive and be the switch whether something is feasible or not, is what's the offshore operations going to look like to do the installation, and likewise also the potential need for towing back to port for major component replacements within the wind turbine. Because for the first projects, that is quite a hard thing to avoid from a nominal design or a plan for doing major component replacement, that you will have to tow back to port. And then it's from a cost point of view, then that affects the floater design, because you need to see which ports you have in the vicinity and ensure your floater can be towed back into these ports to do major component replacements. So it does link back to how you disconnect the cable to make sure it is disconnectable and then easily reconnectable once you take the floater after and these are quite detailed points, but they still actually can influence your base conceptual design, at least of the dynamic cable system, and also likewise the other parts of the system.
Great.
So yeah, so that's some input from, say, how we try to work with the cable design.
Thank you, Michael. That was a very good overview about all the different moving parts there in the project, and there was a nice little commentary there on installation, which segues perfectly to the final panelist, Osman Jepley. who is from Jumbo, the installers, Jumbo Consulting, and Osman. So in the white paper, we did dedicate a section to installation faults and lessons learned from bottom fixed wind. What are you doing at Jumbo to prepare yourself to mitigate installation risk for floating offshore wind?
Yes, thank you for the question and the opportunity to add on what has already been covered by the panelists, which by the way very interesting. To reply, we need to take a broad view of what we do at Jumbo. We support developers. We are a highly experienced group of consultants operating globally in 11 countries. There are more than 80 people. And as I said, we support developers from the early phase consent to the procurement process and FID, contract management, first power. And we operate, of course, with the market leaders like CFP, RWE, and big developers. And in doing so, we have a holistic view on the project, and we look at the whole life cycle of the project. Therefore, this entails that we have a great look at the program, the interfaces of the various components, and the costs related to the project. With this in mind, we always start at the requirements that the specific project has, always looking at the data and the particular customer, in this case developer, needs. And in doing so, we have a whole plethora of best practices and highly developed and specialized tools that we use across all the projects that we are developing. We have developed more than 7 gigawatts of projects, and we are currently supporting more than 19 gigawatts of projects. Therefore, we can draw upon the best practices on the industry. And this entails having risk management tools, evaluation tools, and risk mitigation tools in hands. And this goes, as we said, in providing more confidence to the industry, as Ralf said, from an insurance perspective. Not only this, of course, and we also develop mitigation strategies ourselves, integrating the various components of the wind farm. So not only on the specific packages, because as one of the most important things, as Michael said, is the interface between various parts of the wind farm. And if you allow me, I mean, just quickly on the specific installation part challenges, we already have solutions. I mean, as John said, we already have solutions that has been implemented, that has been developed, not only in oil and gas, but already in early phase pilot projects. And these, of course, are related to how much, what's the balance between the time that we dedicate onshore versus offshore. Because of course, risks and costs increase when we have time offshore. And what are we talking here specifically? Well, basically, it's about the solution that you put in place. So you have many dynamic accessories that needs to be refined, that are already available, but needs to be developed properly. And these can be either pre-fitted in a sort of pre-termination fashion onshore, and the manufacturing facility needs to be equipped with the location, the necessary equipment to do all these operations, the stripping of the cable and the fitting of the bend stiffener and all the other components, versus, of course, doing these operations offshore. This is one of the major solutions that, from an installation perspective, this is the major dichotomy that I would say would impact the execution of the project, and have go a long way in terms of de-risking the project versus having higher cost and time offshore. Of course, not only this, but the overall solution at the end, based on the lazy wave or the integration of the weak link connection, and of course pooling, determination testing, and all the other activities that are done on the floating platform, foundation offshore. These are highly impacting the overall installation solution. And therefore, I would say, just to summarize it, best practices, risk assessment tools, mitigation plans, draw upon the current solutions developed and that are going to be developed in the market, and put the knowledge forward, drawing from the early phase pilot projects that we are currently developing.
Okay, great. Thank you, Osman, for the perspective there from an installer. So I will invite people, if they have questions, to type them into the chat. We've had one question so far, and that is about subsea substations rather than floating substations. And I might address, feel free for anyone in the panel to take this question, but it's how do we maintain and repair subsea substations after they're installed? As an example is you need to change the oil exchange in the system. Is that a question for Osman in terms of operating installation equipment? Or is it for Michael, who's probably thought about those issues? Is it? I'm not sure if. Do you have any comments on that, Osman?
Yes. Well, from a substation perspective, I think the broader question can be said: what do we do to maintain the floating structures and the system that we put in place, and of course the floating substation being one of those. We need to work closely, of course, with installers. One of the options that we have on the market is, of course, the long-term frame agreements in terms of maintenance and repair, for example, not only from a cable perspective, but also broader on the various packages that are involved in the development of a floating wind farm. And there's already various options on the market from leading installers and cable manufacturers that offer this sort of services. So I guess in terms of development on the industries from an installation perspective, this is definitely something that can already be pursued on the market. And additionally, I would say new technologies like the usage of drones, perhaps, that we have seen already emerging from turbines perspective, could also be employed in the floating substations. And additional non-man needed, let's say, devices can be adopted. So, of course, this question can be declined from many perspectives, but if we use it in terms of maintenance and repair, this could be one of the options.
Okay, Ralf.
Yes, I often hear this discussion, and I have a real question. Should we perhaps address the aspect that we need to build a subsea substation, which, in case of a major component replacement, has to be floated? So I think once we are able to do that, I think then we can have subsea substations. The reason why I'm talking about that is that even in bottom fixed offshore wind, in the past we had necessities to replace the transformer. So it was there. So it's so I would say as early as we are able to have a real concept to exchange the major components, and I'm not talking about normal maintenance, then we can talk about subsea substations. A very interesting concept, I think, because of course it brings a lot of silence into the project. So we don't need dynamic export cables, for example. So it's very exciting. And I'm working also on a lot of onshore cable losses in the grid connections, and we have a lot of advantages if we are bringing things on the seabed because we have no longer movement. So fully understood, but I think we have to much deeper to dive into the major component replacement.
Okay, great. So the questions are coming in thick and fast now. I think faster than we can keep up with. I'll just get through one or two of them quickly. What are the main challenges of using dynamic cables at limited water depth? I can address that one. It's actually harsh conditions at shallow water depth are the most severe to try and design for because of the amount of displacement and tolerance that needs to be taken up for. With such a small configuration, you can't get enough compliance in it. So it's really, when you're dealing with harsh conditions, shallow waters, it can be really challenging. You might have the same sort of extreme wave height, and as a percentage of the overall length of the cable, it becomes a lot larger and becomes really challenging to do that. Another question, what are the development plans of suppliers? So most facilities fully booked, and if so, as most facilities are fully booked for the foreseeable future, is there space for dynamic cable production? Does anybody know the answer or comment on the lead time for dynamic cables?
Maybe I can at least give a bit of an input from what seems to be out, is that it's the high uncertainty around the floating wind farm projects are not that does not inspire large confidence with dynamic or cable manufacturers, because they would like, as you say, they want to make sure that if they're going to invest in new facilities, there's a good commitment to, or that they're going to be being used. So there's some uncertainty in that regard. And then it's also about how many cables and what's the profitability of those cables. So
Yep.
It is challenging because you are also competing with other industries for the same, from the same suppliers. So then it's more of ensuring that the projects are going to happen and they can commit to procuring cables long term, to be able to facilitate the suppliers expanding their capacity to supply the cables needed.
Yep, and cables are a large component of the cable is the cost of the copper conductor or aluminium or whatever, and so those companies are looking at the margins in each of those, and some might be turning more towards the export cables where they need a lot more copper than the inter-array cables, that sort of thing. Another question: have you used, I guess you as the floating offshore wind industry, have you used the experience developed by the oil and gas contractors who are familiar with these kinds of problems, flexible pipes, umbilicals, etc.? I think the answer to that is yes. A lot of the suppliers, pretty much all the cable manufacturers are oil and gas originally. A lot of the component manufacturers are. There's obviously startups in different areas, but they do heavily rely on the experience of the oil and gas contractors. Probably a good point is maybe to talk about the differences as to where you would not rely on the oil and gas experience. Does anybody have any thoughts on that? I mean, the biggest one I can think of there is the common mode failure scenarios where in oil and gas you might have one component fail and you fix it, but in, say, floating wind, that one component can fail across 100 units, and so there's a lot more, you have to have a lot more sensitivity to that type of common mode failure. Does anybody want to elaborate a bit more on any thoughts there before we go on to some of the other questions? No, so next is the panel's opened up a large number of possibilities that need to be evaluated with the inclusion of the holistic approach because these systems all interlink. Can you give some recommendations to narrow the number of configurations that need to be looked into? Is that something you want to comment on, John?
Well, the number of configurations of what exactly? What are we talking about? Are we talking about the entire system? I think again, just to, I mean, for me, what I see is that there's just too much uncertainty, lack of definition at this stage. You know, what we're using for, you know, I mean, we're for example, there are no specs. Going back to the previous question, what we're using, we're using oil and gas standards to design the best inlets today because we don't have them for the floating industry. I don't really know, to be honest. It's difficult to comment.
Yep. Okay.
Yeah, maybe I can supplement with that. So that is sort of, at the moment, it's due to the uncertainty, one tends then to go towards, for these initial or first commercial and pre-commercial projects, is to go to something that has less risk, because, and that might result in a higher cost, but it is there, that higher cost is being paid to do risk reduction, or to reduce the risk for future projects. So you will end up going towards, if you have to choose between 4 configurations, you will go for, or a number of configurations, you go for this one that is a bit more towards being low risk for the first ones, because of the uncertainty and the novelty of the technology in terms of floating wind. So probably the more novel ones can be ruled out to some extent for the first projects, but they are, because it's not from a technical point of view, but from a whole cost risk picture point of view, that those decisions would be taken.
Yep, great. Ralf, did you have a comment there?
Yes, we had a long time elaborated on that, and but this is only my personal opinion, just to bring something into the discussion, and also I think confirmed by the latest O&M examples in the current offshore wind projects in floating. I think one of the biggest consequences of risk, which at the moment we are not able to change, is the serial defects risk of the turbine. The next is, once I learned from the oil and gas experts, especially from AMOC and others in our insurance subcommittees, is the failure rate of mooring lines, which we have to accept, and then to think about the consequences, what we are doing with these 2 informations, because these 2 informations are then linked how we are handling the dynamic cable risks. So I think this answers the question, at least partly, with respect to this necessary holistic engineering, because the first step of holistic engineering, a very important one, is to bring the knowledge about the floater, the mooring lines, the dynamic cables, and the turbine together. I hope this answers at least a little.
Great. Yeah, no, thank you for that. We've just about run out of time now. I will just quickly try and address 2 other questions regarding global layout, the advantages of fishbone and star compared to daisy chain. Fishbone and star, I think, offer more redundancy, but have greater expense, more cable to be deployed. For these type of dynamic cable configurations, is VRV considered a key design case? I hope so. VRV is certainly my pet area, and I'm hoping that people will take it seriously. It certainly caused a huge problem with a fixed bottom wind off the United States. So I think we'll close it up there, pass it back to Ilya, and I'd personally like to thank the panelists that joined today to help with their contributions to the discussion. That was very enlightening, and also thank the attendees that turned up, and Ilya from WFO, and Louise, who hasn't shown as a key part in this, but she certainly prepared a lot of the background. So pass it over to you, Ilya.
Okay, yes, great. Thank you very much. I really appreciate your time today, that you were able to join us and share all of your expertise with the audience, with the global audience. This webinar has been recorded, and then in a few days it will be publicly available on our YouTube channel, so more people can actually see and view it. And yes, if they have any questions, they may reach you directly after the webinar. But for now, yes, thank you very much for today. We really appreciate. Thank you very much, Hayden, Michael, John, Ralf, and Osman, for your time, and see you next time.
Thank you.
Thank you.
Thank you.
Thank you.
Bye-bye.